Can you imagine a world where we don't have electricity, no light switch to turn on, no computers to turn on, no hot water, and way more? Electricity is a big part of our lives, and sometimes we don't even realize it. But in reality, electricity has always existed naturally. For example, lightning is simple a flow of electrons between the ground and the clouds. And when you touch something that gives you a shock, it is actually electricity moving towards you. People were initially afraid of electricity, and parents would not let their children near the lights. Thomas Young was the first to use the word energy in its current sense, replacing the traditional term vis viva, meaning living force. So, today we are going to start the new chapter, electricity. Yes, we all know what electricity is, but exactly what is it? Where does it comes from? Can you see it? How is it created? We'll discuss about different points of electricity. In this chapter, we'll learn about the definition of electricity, electric current, electric potential and potential difference, electromotive force, electric circuit and components, current and voltage measurement. What is electricity? Electricity is a form of energy that can be easily changed to many other forms, such as electricity used for formation of light. As an example, floodlights, flashlights, lamp, incandescent light, etc. Electricity is also used for heating or cooling purpose, like oven, iron, refrigerator, air conditioner. Similarly, electricity is used for the communication systems like computer, phones, radio, TV, or it is also used for the motion or power like motor, car, blender, drilling machine, etc. In other words, electricity is a force created by a difference in charges, positive and negative, due to the gained or lost electron. Charges are mainly three types. For electrons it is negative, for protons it is positive, and for neutrons it has no charge. All of these three are fundamental particles of an atom as well as different matters. Electrons has minus 1.6 into 10 to the minus 19 coulomb of charge, and proton has same charge but it is positive. Just like the magnet, like charges repel each other and unlike charges attract each other. Means when an electron comes near to the another electron, they will repel. But if the electron comes near a proton, then they will attract with each other as they have the opposite charges. So what are the difference between conductor and insulator? Let's see. Conductor are these substances which has the property to conduct electricity through them. But insulator has the property to obstruct to flow the electricity through them. Secondly, conductor have freely or loosely held electrons which helps in conduct electricity. On the other hand, insulator do not have any free electrons. So what is electric current? When electricity is flowing between 2 points, this is actually electrons moving from point A to point B, and this is called electric current. We all knows that water always flows from hill to plane surface, that is from a higher level to the lower level. Similarly, electric current is the flow of charge from higher point to a lower point. Electron flows in the opposite direction of the flow of current. Means electron always flows from negative part, that is the electron denser part, to the electron deficient positive part of any of the circuit. As a result, electricity or current flows always from positive end to the negative end. Hence, electric current is the ratio of flow of charge and the time of flow of charge. It is denoted by I, and I is equals to Q by T. Q is the denotation of flow of charge and T is the denotation of time of flow of charge. The SI unit of current is ampere, which is denoted by capital letter A. The current flowing through a wire is said to be 1 ampere when 1 coulomb of charge flows through any cross section of a conductor in 1 second. Ammeter is used to measure the electric current. It should have low resistance so that it may not change the value of current flowing. Electric potential and potential difference. Electric potential is the work done in moving a unit positive charge from infinity to a point. And potential difference is the difference of potential between 2 points A and B given in the diagram. Hence, potential difference equals to work done by charge. That is V equals to W by Q, where V is the potential difference between 2 points, W is the work done to flow the electrons from one point to another, and Q is the amount of charge. The SI unit of potential difference is volt. How can we define 1 volt? The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to other. In the given diagram, two wires are there. In the above wire, it is observed that electrons are moving here and there in haphazard direction. But in the second diagram, from A to B, electrons are flowing. Means A point has negatively charged end, it is the higher potential part, and B is the lower potential part, and the electrons are moving always from higher potential to the lower potential. Now, electromotive force. Electromotive force is denoted by e.m.f. and it is the same as voltage. EMF can be defined as the amount of energy supplied by electric source like battery to each unit of electric charge. EMF is measured by a voltmeter like potential difference. Check in the diagram. A voltmeter is placed across the battery or cell and EMF is measured for only the cell or battery. But Potential difference can be measured with voltmeter, and here the voltmeter is attached across the circuit, not with the cell. Here you have to keep in your mind that the potential difference of the total circuit is the EMF of the battery. Now question arises, how does an electrical appliances work? To make an electrical appliances work, electricity must flow through it, and the path along which the electric current moves is called the electric circuit. An electric circuit is an electrical device that provides a path for electricity to flow. In the given diagram, from the cell, positive charge means the electric current is passing through the path as shown, and this path is actually called electric circuit. In a circuit, ammeter's positive end always will be attached with the positive end of the cell, and negative end of the ammeter always will be attached to the negative end of the cell. There are two different kinds of circuit. One is open circuit, another one is closed circuit. In open circuit, bulb does not light up when the switch is open. But in the closed circuit, bulb will light up when switch is closed, as shown in the diagram. Different electrical components are symbolized in different form, and the symbols are given below. Subscribe my channel to get regular updates on different chapters. Press the bell icon. Thank you for watching my videos.